Hello, welcome to Chapter 3 of Core Connections Geometry. We're going to start with Lesson 311, homework questions 5 through 10. Plot triangle ABC formed by the points A, B, and C on graph paper. Use the method used in problem 3-2 to enlarge it from the original by a factor of 2. Label the new triangle A prime, B prime, and C prime. So right now I'm just going to take those points and plot them on the grid. Alright, the points are plotted. We want to enlarge it from the origin by a factor of 2. So we're going to use the idea from lesson 311, problem 3-2. So since it's from the origin and we're enlarging it, but A is on the origin, so therefore that stays in the same place. With C, we moved 3 units to the right, so we're going to move an additional 3 units. So this right here will represent C prime. With B, if you go from the origin, you can kind of think I went 3 units to the right and then I went 4 units up. So if I do that again, this will represent B prime. And then that will give us our new triangle. Alright, and so to answer part A, what are the side lengths of the original triangle? You can just count over here, that's 3, and then on this side it's 4. So we're going to make sure we label these correctly. AC has a measure of 3, BC has a measure of 4, and we're looking for AB. And we can use Pythagorean theorem to figure this out. So we have 3 squared plus 4 squared is equal to, and I'll just identify this as x, so x squared. So 9 plus 16 is 25. What squared gives us 25? That would be x equals 5. Also, negative 5 would work, but since we're talking about a distance, it's not going to apply to this problem. So AB has a distance of 5. Now, on part B, what are the side lengths of the enlarged one? So on part B, now this distance, this full distance on bottom, is 6. This distance over here is 8. So we know that A prime, C prime is equal to 6. We know B prime, C prime is equal to 8. And then to get A prime and B prime its measure, you're going to have to use Pythagorean theorem again. And we'll do that real quickly. We get 6 squared plus 8 squared is equal to, call this one y this time, y squared. And so that's 36 plus 64, which is 100. What squared gives you 100? 10 or negative 10, but since we're doing distance again, it's only going to be 10. And so now we know that the measure of A prime to B prime is 10. And then now we're going to move on to part C. And part C wants us to find the area and perimeter of both of them. So we'll just do the first triangle. We're going to be looking at triangle ABC. And we're going to be talking about the area of that. So that's 1/2 base. We'll just use the AC as the base, and then that will give us a height of BC. And since it's a right triangle, the height is part of this right here. It does represent the height of the triangle, and it is a side length. So now we know the area of the original triangle ABC would be 6 units squared. Okay. Now let's go find the area of triangle A prime, B prime, and C prime. It's still 1/2 base times height, but now we'll use the base is now 6 and the height is now 8. So the area is half of 48, which would be 24 units squared. And then we also want to find the perimeter, and I just realized that it asked for just of the new triangle, but that's okay. We'll go ahead and do both of them now that I've already started. So triangle ABC, the original, we're going to look for the perimeter, and you can just add up the sides, which would be 3 plus 4 plus 5, so we get a perimeter of 12 units. And then what it was really asking for was our new triangle, A prime, B prime, and C prime. And so the perimeter of that, we have 6 plus 8 plus 10. So we have a perimeter of 24 units. So I think we've answered all the questions on this particular problem. Question 3-6. Solve each equation below for x. Show all your work and check your answer by substituting it back into the equation and verifying that it makes the equation true. So on part A, we have x divided by 3 is equal to 6. So to undo that, we're going to use inverse operations, which is to multiply, and we get x equals 18. And so to check that, we just plug it back in. Is 18 divided by 3 equal to 6? And yes, it is, so it does check out. On B, we have 5x plus 9 divided by 2 equals 12. Once again, we want to get rid of the denominator, so we're going to multiply both sides by 2. That will just cancel out the 2 on the left side to leave you with 5x plus 9. And then on the right side, you'll get 12 times 2, which is 24. And now you can subtract the 9 to get 15, and then divide by 5 to get x equals 3. Once again, to check, this would be 5 times 3 plus 9 divided by 2 should equal 12. And that's 15 plus 9 is 24. So 24 divided by 2 is 12. And once again, it does check correctly. On to part C, x divided by 4 is equal to 9 divided by 6. We could do this a couple of different ways, and so I don't want to make you think whatever way I'm going to show you is the correct way or the right way. One thing that I like to do is get rid of the denominator. So I could do it in 2 steps or I could do it in 1 if I know what my least common denominator of 4 and 6 is. And since I know the least common denominator of 4 and 6 is 12, I'm going to multiply both sides by 12. And what that does is it's going to cancel the 4. So 12 divided by 4 is 3. So that's 3 times x. And then 12 divided by 6 is 2, so that's 9 times 2. And what that does, as I said, is it gets rid of the denominator on both sides, and then you can just go ahead and solve, and so we get x equals 6. And as I said, to show the check here, we'll plug it back in. 6 divided by 4 should be equivalent to 9/6. You can reduce those, you can divide them. If I just reduce it, I get 3/2 equal to 3/2, so it does check as well that way. Excuse me. On D, same idea. We have 5 divided by x is equal to 20 divided by 8. Now 20 divided by 8, similar to C on the 9/6, could be reduced. By reducing it, it does make the numbers a little bit smaller. So if I divide both of these by 4 and cancel out that common factor, that'll give me 5 over 2, which actually, if you look at it now, it makes it a little bit simpler because the 5s are both the same on top, so what does x have to equal? X would have to equal 2. It doesn't always work out that way, but that is one way to look at it. If you are thinking, well, what if it doesn't work? Then what do I do? Well, same thing that you did above, but this time you have an x in the denominator. So you could multiply this side by 2 and this side by 2, and so that'll give you 10 over x is equal to 5, and then you could multiply it by x. So then it cancels on the left, and you're just left with 10 equals 5x divided by 5, and x is equal to 2. So you still have the same answer, but if it didn't work the way I showed you before, that would be how you'd finish it off. And then to check that, 5 divided by 2 should be equivalent to 20 over 8. And we already reduced the 20 over 8 by a factor of 4, and so you do get 5/2. So it does check out as well. Question 3-7, examine the triangle below. Estimate the measure of each angle on the triangle above. So you can, try to use a protractor. You can maybe look at it and see if you can estimate it. We're going to call this A, B, and C. That way I can write it down. So I'm going to say the measure of angle A is approximately, let's say, maybe about 30 degrees. The measure of angle B is approximately a little bit bigger, maybe 40 degrees. And then the measure of angle C, if these are my two approximations, I want them to add up to 180. So I'm going to say this one is approximately 110 degrees. It's definitely bigger than 90. It's bigger than a 90-degree angle, so that seems like it works out. So that's my estimates. On part B, given only its shape, what is the best name for this triangle? Well, we can see we have an angle larger than 90, so it is an obtuse triangle. And since it appears that all these side lengths have different measure, then we can maybe even go a little bit further and we can call it an obtuse scalene triangle. And so we include the word scalene, meaning that none of the side lengths are congruent. Question 3-8. On graph paper, graph the line MU given the 2 points. So let's just go ahead and start there. Negative 1, 1. This would represent M. And then 4, 5, this represents U. And since we're doing a line, you can see maybe a little bit harder on this one to see the arrows there. But we are going to extend this out. Alright, so I've drawn the line. Part A, find the slope of the line MU and write an equation for the line. So find the slope. If we use the 2 points that were given, 1, 2, 3, 4. So if we create this slope triangle, we go up 4 and over 5. So positive 4, positive 5. So we have a slope that's equal to 4 over 5. And then to write the equation of the line, it might look like it crosses at 0, 2 on the y-intercept, but let's be certain of that. So let's use our points negative 1, 1. We've already found the slope by using the slope triangle. You could verify that. But let's just go ahead and since we know the slope is 4/5, let's use one of the points and the slope. So y, I'm going to use this point right here with 2 positive coordinates. So 5 is equal to your slope of 4/5 times x plus b. So 5 is equal to 16/5 plus b. And you could also write that would be 15 or 3 1/5 or 3.2. So that's also okay. And then subtract that to the other side to get your b value. So once again, if you want to write that as a decimal because it looks a little bit nicer, you can. If we leave it as a fraction and you subtract 16/5 or 3 1/5, that'll leave you with 1 4/5 or 9/5. And so that gives us enough information to write the equation. Y is equal to 4/5 x plus, once again, you can use 9/5 or 1 and, would that be 1.8 on this one? Alright, on part B, it wants us to find the distance, or find the measure of MU, and so that means find that distance. Well, if we're looking for this distance right here, we've created a right triangle in terms of the slope, so let's go ahead and use Pythagorean theorem to figure out what that distance is. So 4 squared plus 5 squared, I'm just going to call it x squared. So that's 16 and 25. So 41 is equal to x squared. And then you can take the square root of 41 to get that value of x. So x is approximately 6.40 units. And since it asked to find mu, I should write it that way. Mu is equal to 6.40 units. Alright, now on to part C. Are there any similarities to the calculations used in part A and B? Any differences? So on part A and B, so part A was to find the slope, which we found to be 4/5. And then on part B, it wanted us to find the distance, which was mu, which was the square root of 41. So on part A, one is a ratio, so part A represents a ratio. So that's where we went up 4 over 5. It's not talking about the actual distance. Whereas in part B, it wants to know what the length is of that line segment. So once again, on part A, it's asking for a ratio. That's what slope represents. Where on part B, it's looking for the length or the distance between the 2 points. Question 9. Examine each diagram below. Identify the error in the diagram. So on part A, the error in the diagram is you have a length of 3 and a length of 5. You cannot have a length of 9 meters because 3 and 5, the largest it could be is 8, and the smallest that side could be, if you subtract those, would be 3. So it has to be somewhere in between 3 and 8, so 9 is not possible. Alright, part B. We have 5, 12, and 14. If this is truly a right triangle, then let's check to see that 5 squared plus 12 squared is equal to 14 squared. So this is 25 plus 144 is equal to 14 squared is 196. So 25 plus 144 would be 169, and 169 is not equal to 196, so therefore this cannot be a right triangle. Alright, and C. We have what appears to be an isosceles triangle, and if these are both 7, then these angles must also be the same, which means it would be 65. So if that's the case, we have 65 degrees plus 65 degrees plus 55 degrees. It should equal 180 degrees. Well, 65 and 65 is 130. So if we take 130 plus 55, that's 185 degrees, which obviously is not equal to 180 degrees. So therefore, the base angles are not equal. This would actually have to be 60, which then it wouldn't be isosceles. So that's what's wrong with part C. So I just said on that one, the base angles are not equal, and they should be, once again, if it's an isosceles triangle. Question 10. Rewrite the statements below into conditional if-then form. All equilateral triangles have a 180-degree rotation symmetry. So we can say if a shape is an equilateral triangle, then it has a 120-degree rotation symmetry. And I'll write that out in a second. On part B, a rectangle is a parallelogram. So once again, if we're going to do if-then, then we'll say if a shape is a rectangle, then the shape is a parallelogram. So once again, just continuing to work on those conditional if-then statements. And so once again, those are the two statements below, turning the statements A and B into conditional statements, if-then statements.